Good afternoon, everyone. So I want to start by asking you all to imagine for a moment, or for many of you, you probably just have to think about it, but imagine architecting a complex web application like this one. Imagine all of the interactions that you could potentially have to deal with, and realize that all this complexity is really just for this one page. And now imagine how much code there must be to deal with interactions on this scale across not just 1 or 2 or 3 pages, but across, I don't know, say like 20 main pages. And then each of those pages has their own individual subpages. And then you have to handle all these various interactions and complex flows. So my name is Trent Willis. I'm a senior software engineer at LinkedIn currently. And today, I'm here to talk to you about our recent rebuild of our flagship desktop application. The application we built encompasses a huge feature set, things such as user profiles, messaging, a news feed, job searching, and more. And we serve all of this to our 450 million members. Most striking of all, though, is not that we built a desktop application like this, but is that a large part of this application is actually shared code with our mobile web experience. And so we wanted to deliver a consistent and cohesive experience across multiple platforms and have a really deep and rich feature set for users, not just on our desktop, but also on our mobile experience. So in order to deliver all of that in a performant manner for all of our users, we had to push the boundaries of what Ember could do. So today, I want to talk specifically about one thing that we did for this website. And that is work on Ember engines. And specifically, lazy loading engines. And I want to focus on how we at LinkedIn work not just in isolation, but with the Ember community to drive forward solutions to some of the hard problems that we encountered while trying to figure out how to make this a reality. So in this talk, we're going to look at several of the main problems that we faced when trying to get lazy loading engines to work, the corresponding solutions that we had, and the RFCs that we developed to address those problems. And then what that means for you guys as users of Ember, and hopefully users of Ember engines. So we'll also take a look at some of the code that kind of ties it all together, some of the glue code, as Mike would say. But I want to throw out a forewarning, and that this talk is not really about how to build a lazy engine. If you want to know how to do that, I recommend going and watching my talk from the November SF Ember meetup. You can find it on YouTube. Just search lazy engines. I'm sure it'll be one of the top results. Apparently, Melanie's cat thought it was really good, so hopefully you will too. OK, so with that out of the way, let's start with the basics. What is an engine? I gave a talk about lazy engines and never defined an engine, and I got questions afterwards. So to put it more plain, so from the RFC, they define engines as a unit that allows multiple logical applications to be composed together into a single application from the user's perspective. To put that more plainly, what it really means is that an engine is a subset of an application, which really could be considered an application in its own right. So for LinkedIn, this meant different areas of functionality, such as messaging or a user's profile. So while we have messaging incorporated as a subset of our application, and it is part of a larger experience, we could theoretically extract that out into its own standalone application. So for a more in-depth explanation of kind of what engines are and what they entail at a higher level, I really encourage you to go read the original RFC, which can be found on the Ember.js RFC's repo on GitHub. But for now, let's just work with that definition. So given that, a lazy loading engine is merely a subset of an application, which is loaded lazily or just in time, meaning that you get to defer the cost of having your user download and parse and execute large parts of your application until they actually need them. So for an experience that is both broad and deep, like the one we have with LinkedIn's web experience, this is especially valuable as the vast majority of our users are not going to use all of the features that we have. And thus, we really shouldn't penalize them up front by making them download all of the code for all those features. So, lazy loading. In theory, it sounds pretty simple. You know, you just defer loading something until you actually need it. But in reality, it's quite hard. But thankfully, we have worked to make Ember make it easy. Specifically, right now, that's through the Ember Engines add-on. And so most of what I'm going to talk about today is solved merely by installing this add-on. So now that we have that brief background out of the way, let's discuss our first problem. So serializing URLs. The first problem here relates to generating links to engines. Serializing URLs is kind of this vague concept of how you get data to represent itself in a URL for your application. So another way that we can think of this problem is with the question, how do we construct a URL to a lazily loaded route? To understand why this is really an issue, we have to first understand how Ember constructs a URL normally. So let's start with an example. We have a simple link to here. It goes to a route named blog. You all have most likely coded things like this hundreds of times. And so we're going to start by assuming that this route is synchronously loaded, as is the case for normal Ember apps, and right now, even normal engines. So how does a URL for this link to actually get generated? I think most of you may have a somewhat complete idea of how this works, but let's walk through it. So the first thing you need is the URL path as defined in the router. So in your router map, you would define like this .blog, and then give it a path. Next, you need a model. You don't always need a model, but in the case of a route that has a dynamic segment, you'll need a model to populate those dynamic portions of the URL. Then you also need a query params object in case your route needs query parameters. You know, all the stuff that comes after the question mark in the URLs. But that's not it. You also need a route class. There is a fairly infrequently used feature in routes called the serialize hook. The serialize hook is responsible for letting your Ember application know how exactly you take the model that we have before and actually inject it into the dynamic portions of your URL. Then finally, you need a controller class. And controllers are responsible for handling query param serialization. You can define default values, and Ember has some special logic to strip default values from your URLs when you serialize query params. And then after having all of this, you get a URL out the other end. So by and large, this is not a problem for lazily loaded engines, except for those last two things. Because when you're lazily loading an engine, you don't have access to the route class or the controller class until you actually go to the route. So for instance, when we boot up LinkedIn's homepage, we want to generate links to the messaging tab. But we don't actually load the messaging tab until later. And so because of that, with the old way of thinking in like Ember's routing layer, we couldn't actually generate a URL to go to that page because we are missing these classes. So what this really means is our first problem of serializing URLs is actually two problems. We need to figure out how to handle model serialization without routes, and then how we do query param serialization without controllers. So let's talk about this first subproblem. To really grok this, let's look at an example in code. So if we have a simple route called post, and it has a dynamic segment that has a post ID, very straightforward. So normally, you would want to pass just a plain object that has a post ID property, and it will get serialized into this path. This is how it's done in a lot of applications, and by and large, like, people don't have an issue with this. But what happens if you get an object that doesn't map directly into that dynamic path identifier? Or what if you want to use a different property based on some certain circumstances, such as like maybe you have more than one representation for your post object? Enter the route serialize function. So this is a simple hook. It takes two parameters, the first one being the potential model, and then the second one being any query params. Here, we're only going to deal with a model just to keep the code short and relatively easy to understand. So this function merely just says, hey, if you get a model, use the ID property as the post ID. And And so obviously this is a very simplistic example of what you can do, and you can do many more complicated things. So like I said, this works fine as long as everything is present synchronously. But when you start deferring the loading of route classes until later, you're going to have problems. So we had to come up with a solution. So I worked with Dan Gephardt and Robert Jackson primarily on drafting what we called the route serializer RFC. And this RFC simply says its aim is to replace the existing route serialize method with an equivalent method on the options hash passed into this .route within router map. So that may be a bit unclear. So let's, again, look at a solid example. So we have our route from before. If we pull this serialize function out into a standalone function, like this, we can then just pass that purely into the options hash of the router map, like so. And so since the router map has to be loaded synchronously, that is one of the constraints of Ember, because we need to know where all in the application you can actually go, and this is needed for deep linking and things of that nature, then this eliminates needing the entire route class. But this does have one caveat to it. With this, the assumption is that your serialize method is not going to be dependent on route state. This is an assumption that we were okay making because, one, in general, when you're serializing an object to a URL, you shouldn't need stateful information to do that serialization. But secondly, in our code search of all the open source code that we have found related to Ember, via GitHub or whatever, or just consulting with people that work on large applications, we don't know of anyone that actually uses this hook and has state in it. So if you have a use case for that, please let us know. So on to our second problem. We need to figure out how to serialize query params without controllers. I think to narrow the scope of this, because query params are really complicated in Ember, we need to define what are controllers really needed for in regards to query params. Well, it's really just this one thing, and that is default query param values. Default query param values are used to make URLs nicer, and that we strip out any default values when QPs are serialized. This makes our URLs shorter overall and removes potentially redundant data. But these default values come from the controller instance. So much like the issues with routes, we have similar problems here. To show what that means in practice, let's again look at an example. So if you have a simple controller that defines a lang and locale query params, and you define a default value for the lang query param as en, then that means that if we had a hypothetical serialize method, which just generates the serialized output of query params, and we passed in lang, en, and locale UK, the output we'd get is simply just locale equals UK. This is fine for the most part. It is good for our users, but again, is going to give us problems when we want to do things lazily. So the solution we came up with for lazy engines is pretty straightforward. We just don't do anything special for default query params. So what you get with lazy engines is you'd actually have lang equals un also serialized into the URL. So it's worth noting that even though this is a change in behavior, it shouldn't actually break anything, because this value should deserialize into the same exact default value that you previously had, which means that the end result for your user isn't going to be any different at all. So we can summarize this as just with lazy engines, default query params are part of the URL. It's worth noting that this behavior, while right now is specific to lazy engines, is also part of the specification in the router service RFC. And that we want to move away from having to do all this extra work just to generate a URL up front when it's not actually really benefiting our users that much. So right now, for instance, if you were to navigate to LinkedIn's homepage, and since we have links to almost every area in our application from the homepage, we would then have to instantiate all the router classes and the controller classes up front to generate those URLs. And that's really bad, because that's a lot of extra work for a bunch of areas that your user will potentially never go to. So that basically covers our first problem. We handle query params, when we handle model serialization, then we can generate our URLs properly. So on to our second problem, link scoping. Link scoping is in the same kind of space as the first problem, but is actually pretty much completely different. The previous problem was related to generating links outside of an engine before that engine is loaded. This problem is related to generating links within an engine. So specifically, how do we expect linking to be different when operating inside an isolated scope such as an engine? So going back to our link to blog example, I know this is not correct handlebar syntax, just shortened it for brevity. Where would this go? Well, in a normal application, it's pretty easy. It just goes to a route named blog. Straightforward. But where does this go in an engine? Now, I've worked with a lot of developers who usually, because we're working with like in-repo engines instead of engines that are being developed in isolation, they assume that this will just go to the same place that it used to go to. But if we stop and think for a moment about what engines are designed for and used for, we come to a different conclusion. So the first thing that we need to realize is that we want the link to blog to be relative to some scope, because I mean that's how it works in a normal application. But we also know that engines have their own isolated scope, meaning that they don't really have knowledge about their host, and they want to be able to be used independently of a specific application. And so what this really means is that our links need to be relative to the scope of the engine. And so what this means in practice is that this link to blog is actually treated as mountPoint.blog, where mountPoint is the route path at which the engine is mounted. So if you had a user profile engine, for instance, mounted at the route users, this would actually resolve to users.blog, even though you don't write it as such. So to summarize this point, basically, in order to ensure isolation and loose coupling, links need to be scoped to an engine's mount point. If all of your links were relative to the root of the application, then you would be forcing your consumers to have that same specific route hierarchy in order to use your engine. And this is really, really difficult to make sure that things can be reused across multiple applications and just iterated on independently of the host application. It's worth noting, though, that this behavior, while it seems different from normal link twos, really isn't that different. Theoretically, if you think of the application of having a mount point at root, then it behaves exactly in the same manner. It's just that there is no mount point, really. It's just like the root of your application. So the question then is, how do we link outside of an engine? So if all of our link twos are scoped directly to the content that's within the engine, it makes it difficult to actually link to something that's outside of that scope. And there are obvious use cases for this. If you have a blog engine, you will probably want to be able to link to the homepage of your application. If you have a newsfeed engine, you might want to be able to link into the engine of a user's profile, and so on and so forth. So to address this problem, we came up with the engine linking RFC. This RFC was an attempt to define an alternative construct for denoting when you want to link to something outside or external to an engine. It essentially proposes a sibling API to link to and the transition to APIs. And it boils down to this. You have these external suffixed methods or components, such as link to external, or this dot transition to external. Both of these function similarly to their non-external suffixed counterparts, except that the route destination is looked up indirectly. So the fact that we're passing home here doesn't actually mean we're going to a route named home. To see this, we need to see a second part of the implementation, and that is that your engine has to define external routes as dependencies. So here, our engine is defining two simple routes, home and settings. Those of you familiar with engines know that you can also specify services as dependencies, which the consumer is then responsible for fulfilling. In the same way, you can specify these external routes, and your host is responsible for fulfilling them. So what that looks like is this. So you have an application, an Ember application, and it defines its engines that it has. And then for this case, we just named it my engine, and then you specify the dependencies that you want. It's important to note that whereas in the engine, we specify an array of external routes that we want to go to, here we actually provide a map. And so the key is the name of the external route that we have in the engine, and then the value is the actual route path that the host sees. So for instance, our home route is actually at home.index. Our settings route is at user.settings. So when we do link to external home, it is actually pointing us to home.index. Or more clearly, if we link to settings, it points us to user.settings. And so the way that I encourage developers to think about this and approach these problems is that with link to external, you are specifying what you want to go to. It is the consumer's responsibility to tell you where that thing is. This helps ensure that you're coupling things loosely rather than tightly with the host, because if you're specifying where you want to go, then that forces your consumer into having to have that exact location in mind. But most of the time, that's not what our application actually wants. We want to go to a specific thing, and then we don't really care where that is in the host application. They can define wherever they want it to be. So another way to think of this is you can imagine a conversation like so. The engine's like, hey app, I want to go to settings. Where is that? The host then says, settings is located at user settings index. Thanks. So in summary, links within an engine are scoped to that engine. So if you want to link outside an engine, you need to tell your consumer what you would like to go to, and the consumer then tells you where to go to. So on to our third problem, and probably the most interesting and the one that you all actually care about, is loading assets. So this last problem is a lot like our first problem in that it can be thought of as two separate subproblems, really. That is, what are we going to load, and then how do we load it? Both of these problems can be answered relatively easily when you're defining for a specific system. Like if we were to do our own custom artisanal build of engines at LinkedIn, we could easily come up with like a convention that we follow to just say, okay, these are the things we need to load. Here's how you load them. But we wanted to design a solution that wouldn't just work for LinkedIn, but would work for all apps in the Ember community. And then beyond that, we also wanted to come up with a specification that could help not just Ember Engines applications, but any application that wants to lazy load assets. Because there are times where you may not necessarily need an engine, but you still want to defer loading a costly part of your code base, such as if you need a charting library. So let's deal with this first one. What exactly are we going to load? To answer this, we came up with an RFC called the Asset Manifest RFC. And the purpose is really just to propose a specification for how you define what assets are available to load in an Ember application. So it's a JSON specification to describe assets and bundles of assets that can be loaded into an Ember application asynchronously at runtime. In other words, this will tell us what assets are available for loading and how they should be grouped together. This is important because with things like engines, you need to make sure that you have all of the assets for that engine loaded at the same time. If you got like the engine.js file, but you don't get the vendor part of that engine, then it's not going to work properly. So we want to make sure things have a grouping mechanism by which they can be loaded. So it's pretty straightforward, but we're going to walk through it real quick. Thank you to Daniel for using some TypeScript earlier, because the RFC really specifies stuff in kind of TypeScript notation. It doesn't use anything super fancy. It's really just like properties and types. So the first part is we have an asset interface. And an asset is really an object with just two properties, a type and a URI. These two pieces of information are intended to signal how we should load an asset and which specific asset of that type we need to load. This comes into play a bit more when we get to like the actual loading of these assets, but it's important to note that like having these two properties gives you a lot more flexibility than having like a single URL and then trying to do stuff based on like the suffix extension. One tidbit worth noting here is that the interface specifically uses the term URI instead of URL or URN, as it is intended to be generic. And so like, whereas a lot of applications may use fully resolved URLs to define their asset locations, there are cases, such as at LinkedIn, where we may just want to use a CDN hash and then construct the URL on the client. So The next part is the interface for bundles. So we have a simple typecasting of bundle name to string just to make it a bit more clear as to what's going on. But then a bundle defines two properties. It has an assets array, which should be pretty clear, like we need a list of the assets that belong to this bundle. But then there's also an optional dependencies array, which is a list of bundle names. We don't list other bundles because we want to be able to store all of our bundles as a flat map. And so we can then just use these names to go back and look them up again. This prevents having like an overly nested structure and repeating dependencies multiple times in the same manifest. So this all comes together in the actual asset manifest interface. So right now, this only has one property, and it's the bundles property. And this is just a map of bundle names to bundles. Very straightforward. But we decided to add this extra wrapper on top rather than just putting a bunch of bundle names at the top in case in the future we ever have a need to expand this. Maybe there's a different way that we want to group stuff, or maybe there's additional ways that we want to be able to reference our dependencies. We're unsure. I mean, in web development, changes rapidly, so we want to make sure that we give ourselves flexibility for the future. So in this model, we can simply create a bundle for a lazy engine in our manifest, and then that'll let us know all the stuff that we need to load. That's basically it for this spec. It's relatively straightforward. The RFC goes into a lot of detail as to like how we designed everything. So I would encourage you to check it out if you have time and are interested. It's important to note some of the key like criteria and goals that we had in designing this. The first is that using plain JSON makes it easier or makes it clear as to how we could do transforms on this data structure. So if you want to do things like fingerprint all the asset URIs, it's relatively easy. I mean, you can just parse in the JSON and then write it back out. It also provides for compositional loading. Having the optional dependencies in each bundle makes it easy so that way you could specify a bunch of different bundles and then have them depend on each other, rather than having to have just a straight list of assets where those assets may be included in more than one place. Additionally, since the format is largely based on objects, it's easy to extend, and there's lots of room for this. We've kind of, as I mentioned, it gives us a lot of flexibility for the future. And then finally, since the format is just JSON, there's no reason why you couldn't use this same exact asset manifest format in other applications and standardize on a solution. So that way, even if your company doesn't necessarily just use Ember, you could still make it easy to reference, say, shared common like UI components that are loaded asynchronously. So how do we load this? How do we load the stuff that we've defined in our manifest? We drafted an RFC for this as well, because we thought it was important. We call it the Asset Loader RFC. Pretty straightforward. And you can probably guess what this does, but I'll read you a blurb anyways. So the Asset Loader service is an Ember service that is responsible for loading assets specified in an asset manifest. So it's specifically designed to handle loading assets from a manifest. But it also explicitly defines one use case in particular. And so the API for loading these assets is promise-based for integration with Router.js. So this is a specific concern of lazy engines. Lazy engines, in order to load properly, we need to make sure that we're able to pause a transition until those assets are ready. And so we do this by just returning a promise. And since transitions in Router.js are based on promises, we can just wait until the first promise resolves and then chain on the second one, chain on the actual transition. So let's walk through the API for this really fast. So the asset loader has a method. The first one is push manifest. This basically just says, hey, here is a manifest. Put it into your internal data structure. And so that way, when we want to load bundles later, we can just pass you a string and you'll do all the lookup and loading for us. Make it really easy on us. With Ember engines, it's important to note that the initial manifest that gets pushed in here is actually done for you. Like Ember engines will generate the manifest file. There's an initializer that will push that manifest into the asset loader service. And then when you do transitions, it'll just take care of everything for you. So the second part is we have a load asset method. This takes in an asset as defined in the asset manifest RFC. And so this returns a promise that simply enough just either resolves when the asset is loaded or rejects when the asset fails to load. It's pretty straightforward. Then we have a load bundle method. This is much like the load asset method, except for it takes in a bundle name as a string, looks it up from the manifest, loops through all of the assets and all of the dependent bundles and loops through all of their assets and so on and so forth, and then basically does a promise.all, and once all of them have resolved or one gets rejected, it'll let you know what happened. And then finally, we have a define loader method. So this is actually one of the more, I guess, interesting parts of the asset loader. And that is that you can specify a loading function for different types of assets. So by default, the asset loader only defines how to handle loading JavaScript and CSS assets. But if you want to do other things, I don't know, maybe load an SVG in the background or do something in a service worker for some like weird data format that you have, you can define these and let the asset loader handle it for you. You are also able to override types of loaders. So if, for instance, you want to be able to add some custom caching layer or like do some weird transforms with your with the JS or CSS assets that you're loading, you can specify that as well. And you just define your own function. The pluggable interface here we felt was really great because it gives you control over deciding the loading strategy you want to use for assets. It was also a necessity in thinking about using lazy engines with fast boot because the lazy loading that we do on the client is not going to work the same way in fast boot because you are on a server, and it doesn't really make sense that you would make a round trip and like put something in the DOM to go load a JavaScript or CSS asset. Okay, so there you have it. That's the interface for the asset loader. So all of this is just a long way of saying that the asset manifest and asset loader together are what we are trying to push forward as the asset loading strategy for Ember. Not necessarily just for engines, but this is something that we will continue to maintain as part of Ember engines. And so therefore, there's some community assurance that it will continue to be around. So like you can use it for other things. At LinkedIn, we don't just use it for lazy engines. We use it for loading all kinds of various things. So all of this is currently implemented via the Ember Asset Loader add-on, which is under the Ember Engines org on GitHub. So feel free to check it out and mess around with it, even if you don't necessarily want to use Ember Engines right away. What you get is a standardized loading utility that is proven to work cross-browser. That was one of the biggest hurdles in this. It's like we had to get it to resolve and reject promises even back to like IE9. And IE9 does not have the same like load and error events for script and link tags as you have in more modern browsers. You also get a standardized way to define assets that can easily be used cross-application. So you can take the same like asset manifest and plop it into multiple applications and it will work. You also get an implementation that prioritizes compatibility, performance, and extensibility equally. Like these were all things that we needed at LinkedIn, and they are all things that many Ember applications need. We want to be able to load our assets quickly. We also want to make sure that they're compatible across all browsers, and we want to make sure that we give ourselves room for the future. So use Ember Asset Loader to know what you want to load and how you're going to load it. Okay. So I've talked about a lot of issues, a lot of things that we had to figure out in order to get lazy engines to work. I want to end by just saying that Ember Engines right now, with that add-on, you get basically all of this for free. I mean, you can use the APIs that I talked about linked to external, the asset loader, the different query params behavior, and there's not really anything that you need to do other than just install the add-on. So the main takeaway that I have for this talk is that the process of identifying all these issues with lazy loading, revamping the strategy that we used for linking and routing, and designing a kind of cross-browser solution for loading assets was long and honestly, some parts very difficult, and it's not even quite finished. Like a lot of these RFCs have not quite been closed out yet, even though we are actively using them in the Ember Engines project. So if you think there's things that are tweaking, like get involved, let us know how you think we can improve. But at this point, we've arrived at a solid solution for the majority of the use cases that we've seen. And due to collaboration, and this was all due to collaboration across the community. So I like to say at this point that Ember Engines is really a community-driven solution to lazy loading. It's not just something that we at LinkedIn have done. But we actively really do want feedback from the rest of the community. This isn't something that we own. It's not something that we want to own. We want to make sure that we're sharing everything with the community. So don't go it alone. Use Ember engines. Help contribute back. And if you want to get involved, I encourage you to check out emberengines.com, which is the official website for the Ember Engines work, and then also just github.com, emberengines.org. You can find lots of stuff there. We try to keep all the information centralized. If there's anything missing, please reach out to myself or someone else on the Ember Engines team, and we'll try to help you out. We do have some limited bandwidth, but we will eventually get to it. So that's it. That's lazy loading engines. Anything but lazy. Thank you.
We have a short amount of time for questions, so if anyone has.
Has there been any thought in the Ember asset loader for loading different assets for different browsers, or using some other strategy to decide whether to load one URI versus another?
So this isn't something that we have explicitly addressed, but as I mentioned, like with the fact that you can define your own loaders, you could easily implement this on your own just by defining a function that handles URIs, and then I guess since this is all done on the client side, you would probably have to like do either like feature detection or user agent sniffing. So this is something that we likely will not bake in directly, but if there was a community add-on that did it, or just something that you wanted to bake into your own project, should be relatively straightforward to do.